Merl here. Welcome back to Prairie Wings Performance. In this video today, what we're going to be doing is we're going to be talking about speed sensors, whether it be a inline speed sensor, wheel speed sensor, cam or crank sensor, any of those kind of speed sensors. And in more particular, we are going to be looking at variable reluctor sensors or VR sensors. And we are also going to be looking at the science behind them and how we can potentially program those into an ECU. Okay, this is like super basic. This is what a VR sensor is inside, and it is very basic. If you look really close, I just took a nail, wrapped a piece of wire around, just put tape on to hold that wire on, and then I have a permanent magnet that is on there. Now, this is basically a VR sensor. So this would be in your wheels or in camera crank sensors. It would be a sensor like this. Now, the thing about this sensor is it doesn't get power or ground because it generates its own voltage. And I'm going to take and demonstrate that with a lab scope. So let me get set up over there. First of all, what I'm starting with is stuff that, technicians that are doing this probably want to own some version of this. There's scan tools that have it and so on. But what I'm dealing with is I have a Handtech lab scope. It's an 8-channel lab scope. It's fairly cheap piece of equipment. I use it all the time, and what I'm doing is very sensitive. It works very well. Now, I can measure me with it. If you look at the screen, I can measure the environment, the table with it. I can do all sorts of neat stuff with it. I'm not going to get into that. What I have is I have my 2 wires here. I'm going to hook my positive and my negative up to it. And instead of holding the magnet on here just for demonstration purposes, what I'm going to do, I'll get you to zoom in, I am just going to create a voltage by moving it across this magnet. So if you take a look at the screen, you'll be able to see when I put this in there, I get a voltage spike right there. So as it comes across, you'll see the cursor come over here. I am creating a positive and a negative spike. Faster I go, the frequency gets more. The higher I go, I can create more higher voltage, both positive and negative. Anyway, this is a very simple example of how that works. All right, what I'm doing is I'm working on an older vehicle with a cable that drives the speedometer, but I want to have the input of the vehicle speed into the ECU. So what I'm using is an inline little sensor. This is a VR sensor that goes inline of the speedometer. So what I need to do is I am going to be hooking this up to the lab scope. And if we watch on the screen now, I have changed all the scaling because the time and everything is different from me using this archaic way of doing it to this nice little sensor. And so if I decide I'm going to drive slow, ooh, look at that. I wonder if I can make it slow enough. So if I drive slow, I'm going to change my height. We're going to go. So I am driving it and I'm causing this sensor to give us a signal. If I go faster, my height goes up. So what the ECU does, I'm going to go into 2-volt scale. So the ECU is taking that signal now and it is transferring it into speed for the ECU. And you can see that I can even go to a finer scale. So however fast that drill is, that's the speed. So that's how I am taking the information. Now there's no power wires going to this. This is creating the voltage inside of here. But that is how I'm taking a magnet and making electrical current to create a signal to tell me how fast the car is going. Okay, we are in this Megasquirt. Different ECUs might do it differently, but in the Megasquirt, we go into advanced engine. speed and gear sensors. And in here, we are going into a digital. Now, we can have a whole bunch of different sensors in here for the reason in this one would be if you are doing traction control, stuff like that. We're not doing that. All we're doing is putting the input in. Now, it is a digital one, and we only have one clip down for digital frequency in. And I was talking about we have 2 wires. Well, this digital frequency in is 2 wires, and I'm going to show you that wire in a second of how it has to be, the wire that has to be used basically. But we have digital frequency in, and that is consisting of a positive side and a negative side because the pulse goes up and down. And what happens in it is this little sensor here, our little nail with the magnet on is right here. And then we have a wheel with a whole bunch of notches in it, just like on a crank sensor. We'll actually show you the crank sensor on this car, but it's using a Hall effect, which is a different sensor, and we can get into that another day. But this right here, the amount of teeth in there dictate how many pulses per mile there is. So if your speedometer is off and you put this in, you can actually change this to make it more accurate. And really, that's all there is to it, is telling it that we are going to be using this. We're going to be using this. We're not using any of the other stuff, but our one speed sensor coming in is all taken care of in this one little section. So as far as the ECU, it's in. We'll have to change this. I don't even remember how many teeth are inside this speed sensor. So we'll go look at the crank sensor on this. So this is the crank sensor, and you see there's teeth all the way around. And but we are using a Hall sensor, which is a 3-wire sensor on here. We'll do a video on that one day. But for now, basically, that's what inside that sensor looks like, except for this would be a 2-wire sensor. And yeah, that's her. Okay, so with a VR sensor, you got to be very careful because we'll say these sensors are leaky, and what they do is they can have erratic current, and we want to make sure that we capture it. So the wire itself looks like this. There's some strings in here you're going to just want to take when you have it prepped up, cut them off, and you're going to end up with 3 leads in here. Now, I'll go into a little bit of detail here of why there's 3 leads. So be very careful when you're using a razor blade. But you're going to want to take this outer coating and you're going to want to carefully cut around it and get to the wire inside. Now, how this looks inside is it has this twisted mesh of wire that we would peel off and twist up like this. Now, you'd probably want to be a little bit more particular, get all the wires in, but this would go to your chassis ground because any of the leakage that comes out of these wires will just go into this and get grounded in the vehicle so that it wouldn't be affecting other sensors, because if you didn't protect these wires, we'd have that leakage going into other wires affecting the sensitivity of other sensors, and you'd have a whole world of problems. So when you're dealing with the VR sensors, you want to make sure that you use this type of wire so that you don't end up with a whole bunch of noise, we'll call it, in other sensors. Thank you so much for watching this. It's really cool that a lot of the technology in cars are based off of very basic things. We got magnets, coils of wire, an iron core. All of this stuff is really basic science, but when someone takes the time to put it all together to hone it, we can really do some really cool things. And that's how all of the sensors in cars work, based off of that kind of sensor. So I'm really hoping that this helps you understand the VR sensors in the car world for speed sensors. And if you don't mind, you know, we have a lot of other car build videos out there. Love doing that. And we're going to have a whole bunch more, lots more of the science about sensors and so on coming out as well. So please like, share, and subscribe. Have a great day.